Welcome to Simulate 365. Multivariate sensitivity studies allow the simultaneous examination of multiple input and output relationships, and their effect on the simulation results. You have created a flowsheet. Now, you ask yourself the question, does your model represent the real system well? Your flowsheet has multiple input and output parameters. Are the parameters correlated? Your process may have nonlinear dependencies, or show unsuspected interactions between model inputs. Can you run a sensitivity study in a solution space of more than 3 dimensions, so that correlations are revealed? Our Simulate 365 multivariate sensitivity study helps you design better processes. Good modeling practice requires a quantification of how much each input is contributing to the output uncertainty. Multivariate sensitivity studies uncover the impact of an input variable on the output uncertainty. They help to increase your understanding of the relationships between input and output variables in a model, and thereby help to increase the robustness of a model under uncertainty. So first, you understand existing relationships in your model, and second, you can increase your model's robustness. What do we mean by understanding your model? The purpose is to remove dimensions in the model structure that do not contribute to help simplify the model. Identify input factors that influence the model output. Focus on the sensitive parameters to avoid critical operation areas for your process. Improve communication to decision makers by making better recommendations based on the insight you gained about your process. By creating data on your process, you can search for correlations between model inputs and outputs to uncover unexpected relationships and identify sensitive parameters for data reconciliation. To demonstrate the multivariate sensitivity study, we use a distillation column as a case study. We have a feed of ethanol and water. The feed enters the column at an ambient temperature, and we have a column of 20 stages with the feed stage in the middle. Ethanol and water have an azeotrope. This can lead to convergence problems in the distillation column since a complete separation is not possible. To avoid convergence problems, we use the reflux ratio and boil-up ratio as specifications for the column. We want to use the multivariate sensitivity study to create data that allows us to evaluate what is our process solution space. How do we create the data for our solution space? We varied the boil-up ratio from 0.2 to 5 and the reflux ratio from 0.1 to 20 in an equidistant grid with a full factorial design. We want to answer these important questions: which ethanol concentration can be reached? How much distillate can we produce? And how much energy is required for the separation? In this report we are navigating on the solutions. The data has been calculated by the multivariate sensitivity study. The ethanol concentration is highlighted by color in this report. We can see that ethanol concentrations close to the azeotrope can be reached. Higher distillate rates show mass balance limitations in the process due to the limited amount of ethanol in the feed stream. The advantages of the report are that you can detect dependencies and get results in one click. We now want to know, where does the mass balance limitation start to influence the process? Let's start with one example of an optimization goal. We want to have a minimal concentration of 90% of ethanol in the distillate. Which settings lead to that concentration? In this process, this would mean a high reflux ratio and a low boil-up ratio. We now want to determine the ISO line to achieve exactly 90% ethanol in the distillate. Several solutions are possible. All these combinations of the boil-up and reflux ratio lead to 90% ethanol concentration in the top product. Every solution has a different distillate rate and reboiler duty required. The graph shows a Pareto front. We can clearly see where the mass balance limitations influence the process. From this point on, an increase of energy doesn't result in higher distillate rates. This is our Pareto optimal point, where we produce the most distillate at 90% ethanol concentration with the least energy demand. By one click, the optimal settings are directly visible. With a boil-up ratio of 0.8 and a reflux ratio of 3.6, we find our optimal solution. Once the data is generated, this report can be used to define any other optimization strategy. For example, we could examine the maximum concentration of ethanol for a fixed distillate rate or least energy consumption for the highest purity. Let me summarize where our multivariate sensitivity study is better than the one that common desktop process simulators have built in. It is more powerful, more flexible, and has easier access. Unlike common process simulators, the input space is not limited to 2 input parameters, which enables you to sample 3+ dimensions, and you can set input constraints. Your calculations are done in parallel in the background, on a cluster of instances. You can use your own, real machines to build a cluster, or purchase as many Microsoft Azure virtual machines as you need from us. Your calculated data is stored in a database. You can use any meta-heuristic to find the optimal solution to your optimization problem, or use the data to train surrogate models, for example an artificial neural network. You can cover multi-dimensional solution spaces with advanced sampling strategies. We have implemented full factorial design, as well as Latin hypercube sampling, a more efficient space-filling design. You can adapt to multiple optimization tasks by optimizing with different constraints and objectives in one data set. You access the MSS via any browser and from any device. There is no installation needed. All you need is your flowsheet. The MSS comes with an easy-to-use graphical user interface where you can navigate all your flowsheet calculations. It can be operated by anyone since no flowsheet modeling expertise is required. Generated data can be downloaded in Excel format or via the application programming interface. There are no simulator limitations. Get started now and create your own multivariate sensitivity study for free on Simulate 365 dashboard.